Hi, welcome to Analysis of Algorithms. We're going to do the homework problems for Chapter 16 today. Chapter 16 is Greedy Algorithms, which is a fairly easy chapter. We only did really two. We did an activity selection thing, and we did Huffman codes. We also talked about the nearest neighbor heuristic to solve the traveling salesman problem, and we also talked about the fractional knapsack problem and the 0-1 knapsack problem. Okay, and how, this is going back to the class, and how we have a greedy algorithm to solve the fractional knapsack problem, not the 0-1 knapsack problem. Okay, the homeworks for section 16.1, there wasn't any good questions, so I didn't assign it, but that doesn't mean that you're not responsible for that section. You are responsible, and again, the activity selection problem is a very easy problem to read. So I wrote up 16.1, but I didn't write any problems. Okay, in 16.3, that's Huffman code, I only gave one problem, and so I'd like to do that one problem. So today's video will be very short. Okay, so let's read the problem. What is the optimal Huffman code for the following set of frequencies based on the first 8 Fibonacci numbers? So that's the 8 Fibonacci numbers. So you have 8 letters, and again, Fibonacci is you add up the two numbers before it. Can you generalize your answer to find the optimal code when the frequencies are the first n Fibonacci numbers? Okay, and the answer is yes, and we'll see why in a second. Okay, so let's do the Huffman algorithm on this thing. So basically, you're going to pull the two smallest things, which is 1 and 1, 1 and 1, and you're going to put them together and you're going to get 2. Now, you're going to have 2 and 2, so it's going to be as follows. You're going to bring these two together, and so you're going to get 4, let's write it here, 4. One of them is going to be a 2, and one of them is going to be a 2, and this one's going to be 1 and 1. Okay, so you dealt with this, this. Okay, and the next thing is you're going to choose a 3. So it's going to be as follows. You're going to have 7. 3 is here. 4 is here. 4 is going to have a 2 here and a 2 here, and this is going to be a 1 and a 1. Okay. And so that takes care of that. Now, next two smallest things is 5 and 7. So let's do that. You're going to have 5 over here, okay, and 5 and 7 is 12. Okay, and now I can do this because I have an eraser. You don't. You have to rewrite. Okay, so the next thing is going to bring in the 8. So 8 and 12 is 20, so you're going to have an 8 over here, and a 12 is 20. It's going to be like this. Okay. The next smallest thing, so we got rid of that, the next smallest thing is 13 and 20. 13 and 20, so you're going to bring that together like this. You're going to have 13 here, and 13 and 20 is 33. Okay. And the next smallest thing is, this is going to be gone, is 33 and 21. So you're going to have the 21 over here. So bring it together, and you're going to have 53. Okay? Okay. It's very simple. The main point as follows, is the sum of the previous numbers is always smaller than the next one. So you're only going to have one straight line of trees. Okay, so this is a fact about Fibonacci numbers. If you sum up so these are the summations. 2, 4, 7, 12, 20. These are adding up. 20 is the sum of the first 1, 2, 3, 4, 5, 6 Fibonacci numbers. But that is okay. So you're going to have that. Okay, anyways, it's going to be like this. This is going to be, and again, you can always go on and you can have it like this. This is some fact about the Fibonacci numbers. Okay, but good. Let's write down the letters. You're going to have A, B, C, D, E, F, G, H. Okay, and what are the codes for the letters? Okay, so we go 0 is to the left, 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay? By the way, this is not a good frequency, okay? Because if you look at it, you're going to have, it's not a very short tree. I mean, these things don't show up often, so maybe it's optimal, but it's not a very perfect tree. Okay, good. But it doesn't matter. These are the numbers given, and this is the code for it. So let's write up the code and see if we can see a pattern. A is 1, 1, 1, 1, 1, 1, 1. Sorry. 1, 2, 3, 4, 5, 6, 7 is 1, 2, 3, 4, 5, 6, 7. B is 1, 1, 1, 4, 5, 6, 0. 1, 1, 1, 1, 6, 0. C is 1, 1, 1, 1, 1, 0. Oops. Yeah, right. Okay. D, let's do D. 1, 2, 3, 4. So this is 1, 2, 3, 4, and then 0. E is 1, 2, 3, and then 0. F is 1, 2, and then 0. Let's just make sure. 1, 1, 0. Right. G is 1, 0, 1, 0, and H is just 0. Okay? So that's not a great code. I mean, basically it's given in monomial, how many letters you have. Anyways, but it's very, that's what they want. And again, you can do this for as many Fibonacci numbers as you want, and you'll get just the same long snake of a tree, which is not a very interesting tree. Okay? That's it. That's it for chapter 16. I'm sorry, they didn't have good homework questions to ask in section 16.1, but again, the algorithm in section 16.1 and the example given in section 16.1 is very understandable. That's it. Thank you very much.